Hello class, today we're going to be learning lesson 1-7 in our textbook. It's all about learning how to represent functions as rules and tables. So first let's talk about what a function is. I think that what I want you to really think about is that a function is like a big machine. So we're going to say that this is the function machine. This machine, it takes in different numbers, and when you put them on this conveyor belt and it goes through this machine, come out different numbers. So it kind of turns them into something else. So those numbers that we put in, they're called the input. Does that make sense? You put them in, and they're going to go in the machine, and then out come numbers. We call them the output. All right? Kind of makes sense. The ones that go in are the input, the ones that come out are the output. All right, and these are just specific numbers that you're going to choose for a specific function. Sometimes we call the group of numbers that go in the domain. So if you're ever asked what's the domain of the function, you list all of those numbers that you are going to plug into the function. And the numbers that come out, the whole group of them, are called the range. This is just some important terms that you need to know. Another important term is that sometimes this value that you first plug in is what's called the x value, and the number that comes out is called the y value. So now it's starting to correlate with equations that you might have worked with before. Okay, so the x's are the numbers that you plug in. The y's are the numbers that you get out of the equation in the very end. One more thing that I'm going to say is that another term for these x values is called an independent variable. And that means I can choose any number that I want. It's independent of this function. So I can pick the number 0 to put into my function. I can pick the number 1,000,000 to put in my function. I can pick the number -1 billion and plug it in. There's no parameters for the numbers that I choose. But there is something specific about the output. Those are called dependent variables. And that's because whatever comes out depends on the number that you put in. Okay, so these are just some terms that I want you to think of. And in this lesson, we're going to learn how you can organize these groups of numbers and the relationship from what's being put into the function and what's coming out of the function. The first way that we're going to organize it is by making a table. So sometimes you might see a table set up this way, where really there's only 2 rows. The top row is going to be our input, and the bottom row is going to be our output. Okay, I'm going to go ahead and make up an example for this one, and this is going to be maybe the number of gallons of gasoline that you purchase at a store and how much they charge you. So the input is going to be the number of gallons. So I'm going to write gallons here. And then the output is going to be the dollars, the amount that the machine is going to charge your credit card. So for instance, if I purchase 1 gallon, maybe they're going to charge me $2. And if I buy 2 gallons, maybe they charge me $4. If I fill up with 3 gallons, maybe it's $6, and I can just go on and on. Maybe if it's 5 gallons, they charge me $10. Maybe if it's 8 gallons, they charge me $16. And if I have a really big car and it's 10 gallons to fill up, they would charge me $20. So I can see just by looking at this table that the input are the numbers 1, 2, 3, 5, 8, and 10. It's only the numbers that I plugged in. And then the output would be the numbers 2, 4, 6, 10, 16, and 20. So for every example that you have, you're going to have a different input and a different output. It just depends on what numbers I chose to use for my input. Another way that we might be able to organize this information is from a mapping diagram. And instead of making a table, it's going to look more like a T-chart. And you've seen T-charts before. And in this case, I'm going to have one column that's called the input and another that is the output. Okay. For the input, maybe this is purchasing boxes of Oreo cookies at the store. Okay, and they say that one box is going to cost $5. So I'm going to draw an arrow that's going to kind of map the input directly to the output. One box is going to be $5. 2 boxes, they're going to charge you $10. 3 boxes, they'll charge you $15. And they're going to have a sale for 4 boxes. They're going to say, if you buy 4 boxes, it's going to be the same price as 3 boxes. All right, you can get 4 for $15. And this is still a function, even though the 3 and the 4 go to the same output. That's perfectly fine. What's wrong, though, is if you have a mapping diagram and you notice you have the input and the output, and for some reason you have the number 1, so maybe you bought 1 box of cookies and it was $5, but then someone at the next checkout charged somebody $6. That would never happen at a grocery store unless you had a coupon, but that's not actually the price of it. So you should not be charged $5 for 1 box, but then someone else gets charged $6. That's not anything that would ever happen. So if you ever have a scenario where the input goes to 2 different outputs, this is not a function. So that's something for you to look out for. All right. Now, a function, as shown here, can be represented as a table or as a mapping diagram, but it can also be represented as an equation. Okay? If I'm given all of the information, I can try to relate that information to an equation. So I have right here a table. Okay? And let's say that I'm given an equation that I'm told, oh, this whole function is represented by the equation y is equal to 2x. And I'm also told what the domain is going to be, which means I'm told that the domain are going to be specific numbers. So I'm told that the domain would be the numbers 0, 2, 5, 7, and 8. This is easy to be able to plug these in and set up a table that'll show the relationship between the input, which in this case is the x value, and the output, which is the y. So if my x's are 0, 2, 5, 7, and 8, I can easily plug them in to this equation. 2 times 0 is still 0. 2 times 2 is 4. 5 times 2 is 10. 7 times 2 is 14. And 8 times 2 is 16. So sometimes you might have an example exactly like this, where they just give you what the function looks like as an equation, and they give you a domain, and they just want you to finish filling in this table. And to finish it off, they might say, so what is the range? Well, you look at what the output is. The range are the numbers 0, 4, 10, 14, and 16. And you're done. Okay? Something that might be a little bit more difficult, though, is if you're given a table and they want you to find out what equation represents that function. So, you would just have to work backwards. Let's copy down what this table would be. I'm going to have my input and the output. And this table will already be filled out. So let's say our input are the numbers 0, 1, 4, 6, and 10. And the output are the numbers 2, 3, 6, 8, and 12. So what we're going to try to look for is a pattern. I'm going to put that over here on the side. Look for a pattern from the input to the output. So I'm going to look here. From 0 to 2, what's happening? Is it being multiplied by a number? Or am I adding a number? And I'm looking and it looks like, oh, I'm adding 2. Is that going to be the same relationship for each of these columns? Well, 1 plus 2 is 3. 4 plus 2 is 6. 6 plus 2 is 8. And 10 plus 2 is 12. So I have found the pattern in this one. Whatever my input was, if it was some number, I was adding 2 to it. So my function would be y is equal to x plus 2. And I'm done. So what I want you to do on your own before you come back to class is I have one problem for you. I want you to write a rule or an equation for the function of this table. And then at the very end, I want you to identify the domain and the range. So again, you're going to look for some sort of relationship from what is being plugged in for the input and what is coming out as the output. And come with any questions that you might have when you come back to class tomorrow.